Okay, we're going to take a look at the Module 6 quiz review. Just a reminder that this is over Section 6.1, 6.2, and 6.3. So the first part here is from 6.1, where we are given two functions, f of x and g of x, and we want to find the composition f of g. Now remember, when we found f of g, it was sometimes useful to write it as f on the outside of g on the inside. Or in other words, f of that, x plus 9, because g is x plus 9. So we are taking this x plus 9 and we're plugging it in here into the f function. So instead of 3x plus 1, it's 3 times x plus 9 minus 1. From there, to simplify, you distribute 3x plus 27 minus 1, and then combine like terms, 3x plus 26. Okay, very similar setup for the next one. We have another f of g, or f of, that's radical x plus 9. That means this square root of x plus 9 goes into x for the f of x function. So it's now 7 times the square root of x plus 9 squared plus 3. Again, I replaced x with the radical x plus 9. From there, the square and the square root cancel out. 7 times the quantity x plus 9 plus 3. I'll distribute the 7x plus 63 plus 3, combine like terms, and you get 7x plus 66. Question 3, are the functions f of x and g of x inverses? And then it says back up your answer with work. So just a reminder, if f of g of x simplifies all the way down to just x, then f and g are inverses. So we want to find f of g of x. Again, that's the same thing as f on the outside, g's on the inside. And we want to see if it simplifies down to just x. So I'm finding f of this, x over 2 plus 3 over 2. In other words, this goes into the f function and replaces x. So I have 2 times x over 2 plus 3 over 2, and then a minus 3 at the end. Go ahead and distribute the 2 out. Well, that's 2x over 2, which will simplify. That's 6 over 2, which will simplify, minus 3. That's just x. 6 over 2 is 3. Combine like terms. 3 minus 3 just gives me x, which means, yes, they are inverses because it simplifies to just x. And that would be my work that I'm backing up my answer with. Okay, question like question 4. It says you're given a point, 5, negative 6 on the graph. What would the point that lies on the inverse of that graph be? So remember, that's inverse notation. That just means inverse of f of x. So when you take the inverse, you just switch x and y, which means it's now -6, 5. And that's all. Okay. The next question is actually given an equation, given a function h of x. Find the inverse. So remember our steps here. Step 1, switch x and y. Step 2, resolve for y. So in this function, I'm just going to say it's y equals to make my math work out nicer. And then I'm going to switch x and y. And then I'm going to resolve this for y, which means I have to add 6 first. X plus 6 equals -3y. Then divide everything by -3. Divide it all by -3. So I get negative x over 3. And then minus, well, 6 over 3 is 2, equals y. I just want to rewrite this to be the inverse of that. So I'm going to say it's the inverse of -x over 3 minus 2. That is the inverse function. Okay, question 6. It asks, what's the domain and range of the following exponential functions? Do they have any vertical or horizontal asymptotes? If so, find them. So remember, when we dealt with these, we can always use Desmos to graph. But first, what I need to find is the domain and the range. Domain for all exponential functions. We know it's exponential because it's raised to the x power. The domain for all exponential functions is -infinity to infinity, all real numbers. Remember, the range came from that guy. So this graph is going to go up because it's +4 times 3 to the x. So the range is going to be -2 to infinity. Again, you can always check that on the graph, from -2 up to infinity. Now the vertical asymptote, again, on these guys, there's never going to be a vertical asymptote. So let me actually make a note here. This is always the case. Vertical asymptote, none is always the case. Now horizontal asymptote always corresponded, again, with this number at the end. So y equals -2. Our second example, domain, all real numbers, -infinity up to infinity, always the case. Our range, again, has to do with the number we're adding at the end. In this case, because it's a negative, it's going to open down, which means it's anything from -infinity up to 5. So from -infinity to 5. Vertical asymptote, again, none. Horizontal asymptote corresponds to that last number, y equals 5. Okay, last thing we did was solve exponential equations. So to solve these exponential equations, we looked at using exponential law. So we need to get the same bases. Get the same bases. So we have a base of 4 here and a base of 256. Probably a good idea to look at 256 and see if we can break that down to see what base of 4 it would be. So if I could break this down, I bet it divides by 4, and it does. 4 and 64. We know 64 is 4 and 16, and 16 is 4 and 4. Now I'm going to stop at these 4s because I know since this has a base of 4, I can just write 256 as 4 to the 4th. Now if you want to keep going to 2s, you can rewrite them both with base of 2 as well. But I'm just going to stop at 4 because that's 4 to the 4th power. And then when I drop the bases, I know that the exponents can be set equal to each other. So in this case, x is 4. Okay, our next one, we've got a base of 1/3 and a base of 81. Let's start with the 1/3. We know with fractions, to move this up to the top, we need to make the exponent negative. So 1/3 is the same thing as 3 to the negative first. Now with 81, I know that's 9 and 9, and then that's 3 and 3. Another 9 is 3 and 3. Whoops. Those are 3s. So 81 is the same thing as 3 to the 4th power, which means I can rewrite this as 3 to the 4th. From here, I have some powers raised to powers. Remember, those get multiplied to each other. So it's 3 to the negative x minus 1. From there, we can drop our bases and say the exponents are equivalent. So I will solve from here. Add 1 to both sides. 5 equals negative x, which means x is negative 5. Okay, and lastly, we've got 2 fractions. So, with these 2 fractions, I want to definitely move them up top. So we need to remember negative exponents. But I'm going to break them down first. So let's break down 64. And we kind of already did that before, but 64 you can do, 4 and 16. 4 is 2 and 2. 16 is 4 and 4, and then we've got 2 and 2 off of those. So we know 64 is the same thing as 1, 2, 3, 4, 5, 6. 2 to the 6th power. (16), again, if we break that down, we've got 2's, so 16 is 2 to the 4th power. Now remember, these both need negative exponents because they're on the bottom right now. So this is actually 2 to the negative 6th. And this is actually 2 to the negative 4th. We need to distribute. So 2 to the 18x minus 6 equals 2 to the 8x plus 20. You can cancel your bases and say 18x minus 6 equals 8x plus 20. I'm going to subtract 8x. Add 6. 10x equals 26. Divide 10. X equals, well, I can simplify that down. If I take a 2 out of both of those, that's 13 over 5. And there's my fraction, 13/5.